Alright guys, this is the third video for the inverse trig functions, and it is a video with me walking you through the solutions. So if at any point you get lost, crap, I gotta go to dinner. Oh man, I'm going to dinner soon, but these solutions are very important, so I'm gonna record this video. Alright, so yeah, if at any point in time like you get confused or stuck, definitely feel free to call me. But first, what I want you to do is go through the video again. If it's something that you're completely lost on, definitely give me a call. Also, if it's something that you just aren't too sure about, drop me a text or just rewatch the video as many times as you need to in order to make sure that you get it. Alright, so sample problem number 2, the answer was a negative square root of 3. Negative square root of 3. For your turn to drive problems. So I'm just going to walk you through the first one and then I'm going to give you the answers to the rest. So the first one, the way that I thought through it is that we're looking for the arc sine of negative square root of 3 over 2. So I'm asking myself, what angle will give me a sine of negative square root of 3 over 2? Okay, well that angle is going to be my answer because I'm looking for the arc sine, or the inverse sine is the same exact thing. So what angle will give me the sine equal to a negative square root of 3 over 2? Well, first of all, I gotta think, okay, what stores can I go shopping in? For sine, I can go shopping in store number 1 and store number 4. For quadrant number 1 and quadrant number 4. Where is sine negative? Sine is negative in the fourth quadrant, right? So I went ahead and drew my triangle in the fourth quadrant. I'm looking for that angle. Is there a special right triangle that I know that will give me the answer, or that will give me a negative square root of 3 over 2? Yes, the 30, 60, 90 triangle. You know that opposite of theta, because we're talking about sine, opposite has to be negative square root of 3 over 2. So theta has to be negative 60 degrees. Negative 60 degrees is equivalent to negative pi over 3. So my answer is a negative pi over 3. Remember, I always want radians. Always want radians. For the second problem, you walk through it the exact same way. Let's see. So the second problem you walk through it the exact same way. You're looking for what angle will give you. So you're saying what angle will give you. What angle will give you a cosine equal to the square root of 3 over 2? Well, a positive cosine square root of 3 over 2 has to only occur if we're only shopping, first of all, in the first two quadrants. We can only go shopping in the first two quadrants because we know that quadrant 1 and quadrant 2 are the shopping quadrants for cosine. We went ahead and drew our special triangles. We saw that the arc cosine, or what the angle of cosine that equals square root of 3 over 2 was, what was it? Oh yeah, 30 degrees. So 30 degrees, we take the secant of 30 degrees. Well, what is secant? Secant is hypotenuse over adjacent. So hypotenuse over adjacent of 30 degrees. Or you can say it's 1 divided by the cosine of 30 degrees, which gives us 2 square root of 3 over 3. 2 square root of 3 over 3. That was for number 4. For number 2, the cosine, so the inverse cosine of square root of 2 over 2, or the, arc cosine of square root of 2 over 2, it's the same exact thing. All we're doing is we're looking for the angle of cosine that gives us a positive square root of 2 over 2. The only quadrants that we can shop in for cosine are quadrant number 1 and quadrant number 2. So cosine is only positive in the first quadrant if we can only shop in 1 and 2. So that theta angle has to equal 45 degrees, or pi over 4. Number 5, since it's right next to it. The tangent of the inverse sine of 2. Well, what angle does sine equal to? Do we have an angle where sine is equal to 2? I don't think so. So if we don't have an angle where sine is equal to 2, what angle would that be? Like, what would we call that? We'd call that undefined. So if we were to take the tangent of some angle that doesn't really exist, then it's undefined. Alright, cool. So let's see, the last problem, arc cosine. So the arc cosine of the cosine of pi over 3. So this is a little tricky. Not really. It's supposed to be a little easier, but what I wanted to do is, I guess, change it up on how I gave you the problem. So the first problem, it says, the first we're going to start with the inside. We're saying the cosine of pi over 3. Well, the cosine of pi over 3, we know the cosine of pi over 3 is equal to, we know we can use our special right triangles. We're not looking for the arc cosine, we're looking for the cosine. So that's equal to square root of 3 over 2. Or no, the cosine of pi over 3 is equal to 1/2. So the cosine of pi over 3, yes, is equal to 1/2. So after we find the cosine of pi over 3, which is 1/2, what we did was we now have to say, okay, well, I have to do my outside operation, which is the arc cosine of 1/2. So what angle of cosine do I know if I'm shopping with cosine in the first or the second quadrant, because that's the only two quadrants I can use for cosine. What angle of cosine equals 1/2? Well, that angle has to be pi over 3. So pi over 3. A quick trick is that anytime you have the inverse function and the function right next to each other, they'll just cancel. So if they cancel, you're left with whatever you were originally looking for. So pi over 3. See, pi over 3 right here, and pi over 3 as your answer. For the bottom part, these were slightly more challenging. All you had to do was draw out your special right triangles and consider what these operations mean. So the first one, oh yeah, a correction by the way, I said a negative 5 over 13. To simplify it and to make it a little easier, what we're going to do is make it a positive 5 over 13. So what we did is made it a positive 5 over 13. So the arc sine of positive 5 over 13, I went ahead, drew my special right triangle, because I know that if I'm looking for the arc sine of positive 5 over 13, I know it's probably not that clear, but there you go. So if I'm looking for the arc sine of a positive 5 over 13, then what I'm looking for is the angle that gives me 5 over 13. 5 over 13 being the angle where my sine is equal to 5 over 13. Well, we know by definition that sine is opposite, so opposite over hypotenuse. Opposite over hypotenuse, 5 divided by 13, that's how we know that one of the legs, that is the opposite leg, has to be a positive 5, and the hypotenuse has to be 13. How do we know that, you might ask? Well, that's the definition of sine, because if we're looking for the arc sine of 5 over 13, we know that whenever we see something like that, we have to ask ourselves the question, well, what is the value, or at what angle theta is our sine equal to 5 divided by 13? So, okay, well, we know that. So whenever we have a right triangle, we can figure out our other side. Well, we just use a squared plus b squared equals c squared, and that gives us the other side of 12. So the other side is 12, if we say a squared plus b squared equals c squared. So now we have to perform the outside function, where it says the cotangent of whatever angle that we found. So cotangent of theta, what is the cotangent of theta? Well, the cotangent we know is equal to the opposite. So we know that cotangent is 1 over tangent. We already have our theta. We don't have to find an exact value of that angle because we have another function to do. So we said that the cotangent of some angle theta has to equal our answer, right? So what's the cotangent of this angle? Well, we know that cotangent is the same as 1 divided by the tangent. Or it's adjacent divided by hypotenuse, which is 12 divided by 5, which is our answer. So 12 divided by 5 is that answer. The next one is slightly trickier, but you guys can do it. So I think I'm out of time, but I'm just going to keep recording. So that next one is arctangent of x divided by 2, the secant of the arctangent of x divided by 2. Well, the arctangent of x divided by 2, basically it's asking you for what angle is the tangent equal to x divided by 2. Well, you know that the tangent is equal to x divided by 2 at what angle? Well, it has to be positive, so you know it's going to be in the first quadrant for tangent. Can't be in the second quadrant, but you know that you can go shopping in the first or the fourth quadrants for tangent. And then you're going to just go ahead and solve it like normal. So if you solve it like normal, what you're going to do is you're going to say, okay, well, I'm going to find my use my special right triangles. I can't use my special right triangles. I'm just going to use my Pythagorean theorem to find all of my sides. When I find all of my sides, I find that a squared plus b squared is equal to c squared. So I find that my c value is equal to the square root of x squared plus 4. Then I can find my secant of my problem that I'm solving. So secant, we know, is hypotenuse over adjacent, because we know that secant is the same thing as 1 divided by cosine. We know cosine is adjacent divided by hypotenuse, so secant has to be hypotenuse divided by adjacent. And we simplify it, so we get the square root of the x squared plus 4, all divided by 2. And the last problem you guys should be able to do based on the first two problems, the previous two problems, and we were able to come up with the square root of 16 minus x squared divided by x. If you have any questions on these problems, definitely feel free to reach out to me. I have to go grab some Indian food because my friend is taking me out to dinner and I can't wait. Deuces.